After being selected by NASA to transfer astronauts from lunar orbit to the moon's surface and back, SpaceX has been very busy developing a Lunar Starship variant. This process not only includes recent testing, like the first integrated test flight, but also interior design and the logistics of traveling to the moon. Just yesterday, we learned more about what life inside will look like. In this case, during a recent event, new details were revealed regarding the size of this lunar lander and what it will be capable of. Compared to other lunar landers, Starship is extremely unconventional and will be unlike anything sent to the moon in the past. This presents its own challenges that SpaceX is working on as the first lunar mission gets closer. With the first demo mission scheduled just next year, we are not far away from seeing this technology in action for the first time. Here I'll go more in depth into the Lunar Starship interior, the flight profile of this massive lander, what to expect in the coming months, and more. Based on the sheer size of Starship, we've known that the lunar lander variant would feature a large interior and capacity for both crew and a significant amount of cargo. Thankfully, just yesterday, during the Human to Mars Summit, Nick Cummings, Senior Director at SpaceX, talked specifically about the inside of this Starship variant and gave us an idea of what to expect. He started by saying, "So, to give you a sense of scale, I was just in our crew cabin, the Starship Lunar Lander crew cabin mock-up in California. I think it was last week. And the crew deck of the Starship Lunar Lander is about twice the size of this stage, and there's room in Starship for multiple crew decks. We only really need one for the Artemis 3 mission," he said. From video of the event, you can get a relative idea of the size of the stage with people sitting across it in a line. As far as the comment about SpaceX only needing one crew deck for the Artemis 3 mission, it will feature 4 astronauts and would provide ample room for both them and any cargo taken to or from the surface. He then commented, "Below that crew deck, there are 2 airlocks that each are about the pressurized volume of a Dragon capsule. So each airlock has about the space of, a human spaceflight vehicle that's flying people to the space station now. And then those airlocks are inside a very large garage, which is about the size or double the size of the stage," he said. Looking at the inside of Dragon capsules highlights the size of these airlocks, which will provide plenty of room for astronauts entering and exiting the lander. The Dragon spacecraft alone is capable of carrying up to 7 astronauts to and from Earth orbit. As far as the overall development, it looks like SpaceX is trying to ease into the Lunar Starship variant and make sure a capable spacecraft is done in time for Artemis 3. In another quote, Nick pointed out that, "The idea is that we're starting with the capability that we need for Artemis 3, and then we'll work towards being able to fly more people for longer durations, adding the ability to land on Mars with the Martian atmosphere, which is a little bit different than landing on the moon, where there is no atmosphere. And so that's how all these things kind of work together to enable a day where we have ideally, hopefully in our vision, hundreds, thousands, maybe even one day 100,000 or more people living on Mars," he said. Based on everything he talked about, among other information, it looks like the lunar variant is coming along very well. What we do know for sure is that the current testing and progress at Starbase will have a direct effect on the timeliness of this mission. At the end of the day, the most difficult and pressing matter for the company as they prepare for this Artemis mission is getting the normal Starship in orbit and capable of going to space and back. Right now, teams are very busy at Starbase with signs of water-cooled steel plates showing up and pad repairs well underway. Not long from now, we can expect another Starship integrated test flight, hoping to perform better than the first attempt. In addition to getting off the ground and into orbit, there are a few different challenges with landing on the moon that SpaceX is working on. To get a better idea, we can take a look at the full flight profile on a typical mission to the moon. The mission begins with launch. Here, liquid oxygen and methane are loaded onto the Starship Super Heavy system, then Starship lifts off. Next, Super Heavy separates from Starship and returns to Earth. Starship then continues into orbit. Starship HLS requires in-orbit propellant transfer in its mission profile. Prior to the launch of the HLS vehicle from Earth, a Starship variant configured as a propellant depot would be launched into an Earth orbit and then partially or fully filled by between 4 or 14 Starship tanker flights carrying propellant. The Starship HLS vehicle would then launch and rendezvous with the already located propellant depot and refuel. From here, Starship performs a lunar transfer burn using the 3 Raptor vacuum engines. The lander would then enter a near rectilinear halo orbit as it awaits the crew. The crew of Orion would then dock with and transfer to Starship HLS, which would subsequently depart and descend to the lunar surface. After touchdown, the surface crew's first task would be to ensure all systems are ready for their lunar surface stay. Then they will rest, eat, and recharge for the first full day of the expedition. During their time on the moon, the astronauts will do scientific work inside Starship and conduct a series of moonwalks, exiting Starship to explore the surface. The astronauts will don advanced spacesuits, exit through an airlock, and descend on Starship's elevator. After lunar surface operations, Starship HLS would lift off from the moon and return to lunar orbit to rendezvous with Orion. The crew then transfers back to Orion and departs for Earth. Although not confirmed yet, Starship HLS could, in theory, be refueled in orbit to carry more crews and cargo to the surface. In contrast to the Starship spacecraft from which it derives, Starship HLS will never re-enter an atmosphere, so it doesn't have a heat shield or flight control surfaces. Compared to other HLS designs that propose multiple stages, the entire spacecraft will land on the Moon and will then launch from the Moon. Like other Starship variants, Starship HLS has 6 Raptor engines mounted at the tail, which are used when the Starship HLS acts as the second stage during the launch from Earth. They are also used as its primary propulsion system in all other flight phases. Within 100 meters of the lunar surface, the variant will utilize high-thrust RCS thrusters located mid-body to avoid plume problems with the lunar regolith. The thrusters burn gaseous oxygen and methane instead of the liquid oxygen and methane used by the Raptors. We recently saw firsthand the power of the Raptor engines and what they can do to a special type of concrete during the first integrated test flight of Starship. Similar concerns are important to consider when landing and taking off from the Moon. This being said, thanks to the unique Moon environment, a lot less thrust is needed to land and take off. In reality, these thrusters may not be needed. Starship HLS is also supplied with electrical power by a band of solar panels around the circumference of the vehicle. Looking at the program as a whole, Starship has been in privately funded development by SpaceX since the mid-2010s, but the HLS or Human Landing System variant is being developed under contracts with NASA. The initial contracted design work started in May 2020, with selection and funding for full development occurring in April 2021, when Starship HLS was selected by NASA to land on the Moon during the Artemis 3 mission. NASA signed a $2.89 billion contract with SpaceX to develop and manufacture Starship HLS, and to conduct 2 flights, an uncrewed demonstration mission and a crewed lunar landing. In addition, in March of last year, NASA announced it would be exercising Option B, an option under the initial SpaceX HLS contract that would allow a second-generation Starship HLS design to conduct a demonstration mission after Artemis 3. Late last year, NASA announced the Option B award of $1.15 billion, and announced that this crewed landing is to occur as part of Artemis 4. The Option B HLS will meet NASA's requirements for a sustainable HLS. These include the ability to support a crew of 4 and longer duration lunar surface stays. NASA plans to award development contracts to 1 or more other companies for sustainable HLS systems. After these systems are available, the Option B Starship HLS would compete against them for missions starting sometime after Artemis 4. SpaceX is continuing to work on Starship and the lunar variant, expected to fly as soon as next year. Just yesterday, we got new details on the interior of this lander and an idea of how big it really is. This space will provide room for a lot of crew or significant amounts of cargo. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.